The goal for today is to sketch the graph of this function using only 3 points, and more importantly, understand one feature of it, why it touches the x-axis instead of crossing it. I want you to notice something. This is actually a perfect square, so our function can be written as y equals x minus 3 quantity squared. This is the same parabola, just written in a vertex form, so its structure is easier to see. We will start graphing with our parent function, which is y equals x squared. This one must be very familiar to us, and we already know its shape, hopefully, and its key points, which are 0, 0, 1, 1, and negative 1, 1. Let's plot them. 0, 0, which is also our vertex, 1, 1, and negative 1 and 1 again, because this is an even function and it is symmetric around y-axis. Now we try and draw a smooth curve. This is the graph of the function y equals x squared. Let's remember these key points. We will need them. Go back to our original function, which is y equals x minus 3 quantity squared. Notice that this parabola has a horizontal shift 3 units to the right. Whatever you see in the parentheses is the opposite of what you want to do. So minus 3 means horizontal shift 3 units to the right, not to the left. Also, our a is 1. It means our parabola has an upper opening because there is no negative sign. And we do not have any vertical stretch or compression because a is 1. Our k is 0, which means we do not have any vertical shift up or down either. Now let's try and sketch our parabola. Remember, our key points are 0, 0, 1, 1, and negative 1, 1. Let's identify our horizontal shift to the right 3 units, which is here. And now let's just pretend, that this is our new y-axis. And the x-axis stays the same. So using this new y-axis, we plot our key points. 0, 0, which is also our vertex. 1, 1, and negative 1, 1. And now we try and draw a smooth curve. This is the graph of our function y equals x minus 3 quantity squared. By the way, with the parabolas there are only 3 cases. Now watch. The first one is when the vertex of the upper opening parabola is above x-axis, like this, or the vertex of the down opening parabola is below x-axis, like this. In this case, these parabolas will never cross the x-axis, and we will have 0 roots, or 0 x-intercepts. The middle case is when the vertex sits exactly on x-axis for the upper opening parabola like this, and for the downwards opening parabola like this. So it touches the x-axis at exactly 1 point. In this case, we will have 1 root or 1 x-intercept. And the third case is when the vertex of the upper opening parabola is below x-axis, like this, or the vertex of the downward opening parabola is above x-axis. In this case, these parabolas will cross x-axis at exactly 2 points, and we will have 2 roots, or 2 x-intercepts. Notice that our parabola is the middle case. It reaches the x-axis exactly once, and that's why it has 1 real root. A root happens when our function y equals 0. So let's set our function x minus 3 squared equals to 0. A square equals 0 when the quantity being squared equals 0. So x minus 3 equals 0, or x equals 3. And this is our x-intercept, or our root, or the x-coordinate of our vertex. As you can see, the graph reaches the x-axis right here and immediately turns around. And that is why it touches the x-axis instead of crossing it.